a process that changes a rock from one form to another rock cycle. The rock cycle is the ongoing transformation of rocks through stages like melting, cooling, eroding, and compacting. Imagine trying to decide what to wear in unpredictable weather, where you constantly need to change your outfit to suit the conditions. This is similar to the rock cycle, where rocks change form in response to varying environmental conditions, like heat, pressure, and erosion. Just as you might switch from a raincoat to sunglasses to a sweater depending on the weather, rocks transform from igneous to sedimentary to metamorphic, adapting to the conditions of their surroundings over time. Particles of rock and other materials deposited by water or wind. Sediment. Sediment is the tiny pieces of rock and remains that settle at the bottom of bodies of water or are carried by the wind. Imagine cleaning out your handbag or backpack and finding a mix of crumbs, dust, and small items that have settled at the bottom over time. This situation is akin to sediment, where particles of rock and other materials gradually settle out of water or wind and accumulate in layers. Just as these small items and debris in your bag are deposited by the daily winds and waters of your activities, sediment forms when particles carried by natural forces settle out of suspension and collect in a specific area. Igneous rock that forms when lava cools on Earth's surface. Extrusive rock. Extrusive rock is formed from lava that cools quickly on the Earth's surface, creating fine-grained textures. Imagine you're baking a cake and it overflows from the pan, creating a mess on the oven floor. This is similar to how extrusive igneous rocks form, when molten lava spills out onto the Earth's surface and cools quickly. Just as the cake batter solidifies into a new layer on the oven floor, the lava hardens into rock, forming a crusty surface layer. Both processes involve a hot flowing substance spreading out and solidifying into a new form. Igneous rock that forms when magma hardens beneath Earth's surface. Intrusive rock. Intrusive rock is a type of igneous rock that solidifies from magma beneath the Earth's surface. Imagine you've baked a cake, but it takes a long time to cool down in the center because it's surrounded by the warm oven and hot cake around it. This is similar to how intrusive igneous rocks form, where magma cools slowly beneath the Earth's surface, insulated by the surrounding rock layers. Just as the cake's center gradually hardens surrounded by warmth, magma solidifies into igneous rock while hidden beneath the Earth's crust, resulting in a dense and coarse texture. A process where sediment grains are cemented together. Cementation. It is when minerals fill the spaces between sand grains, gluing them to form solid rock. Have you ever tried to make a sandcastle at the beach, only for it to fall apart because the sand was too dry? Just like how adding a little water helps bind the sand grains together to form a stable structure, cementation in geology involves minerals precipitating from water and binding sediment grains into solid rock. In this analogy, the water acts as the minerals in geological cementation, and just as the wet sand forms a sturdy sandcastle, the mineral-laden water solidifies loose sediment into rock. Sedimentary rock that forms when rock fragments are squeezed together, like sandstone. Clastic rock. Clastic rocks are formed from pieces of other rocks, compacted and cemented together. Imagine trying to pack a suitcase with clothes that are too bulky to fit easily. This is similar to how clastic sedimentary rocks, like sandstone, form when individual rock fragments are tightly compacted together. Just as you press and squeeze your clothes to make them fit into the suitcase, rock fragments are compressed under pressure over time to form a solid mass, creating a sedimentary rock. The process of dropping sediment by water or wind. Deposition. It is when particles carried by wind or water settle and accumulate in a new location.
Imagine you're carrying a heavy bag of groceries home, and as you get tired, you start to put down items one by one along the way. This is similar to how water or wind, when losing energy or speed, begins to drop the sediment it carries. Just like you lighten your load by leaving groceries on the path, water or wind lightens its load by depositing sediment, with both processes leaving a trail of items or particles behind in their wake.
Metamorphic rocks with mineral grains arranged in parallel layers. Foliated. Foliated means that the mineral grains in the rock are aligned in flat, parallel layers.
Imagine trying to sort a disorganized pile of laundry into neat stacks of clothes based on type, like shirts in one pile and pants in another. This process is similar to how metamorphic rocks with mineral grains arrange themselves into parallel layers, known as foliation. Just as you organize the laundry into orderly groups, the intense pressure and heat in the Earth's crust cause the minerals in the rock to align into structured, parallel layers, creating a beautifully ordered pattern out of what was once a chaotic mix.
Metamorphic rock with mineral grains not arranged in layers. Non-foliated. In simple terms, non-foliated rocks have mineral grains that are randomly arranged, not in layers or sheets.
Imagine trying to organize a drawer full of mismatched socks, where no two socks are the same, and there's no clear way to group them neatly. This is similar to a non-foliated metamorphic rock, where the mineral grains are not arranged in layers or patterns. Just like the socks that remain ungrouped and scattered, the mineral grains in non-foliated rocks are randomly oriented, lacking the structured layers you'd find in their foliated counterparts, such as how a neatly organized sock drawer might look.
The process by which sediments are compressed by the weight of layers above. Compaction. In simple terms, compaction is when layers of sediment are pressed together tightly over time.
Imagine trying to fit all your clothes into an already full suitcase by pressing down on the pile to create space. Just like this, in the natural world, sediments are compressed by the weight of layers accumulating on top of them, squeezing them tighter together. Think of the clothes as sediments, and the act of pressing down as the weight of additional layers. Both processes involve reducing space and increasing density through pressure from above.
The rock that forms when existing rock is changed by heat, pressure, or chemicals. Metamorphic rock is rock that has been transformed from another type of rock due to heat and pressure.
Imagine trying to transform your messy room into a neat, organized space without adding or removing anything. This is akin to how a metamorphic rock forms, where existing rock is transformed by heat, pressure, or chemical processes without adding new materials. Just as tidying up your room involves rearranging and changing the state of what's already there, metamorphic rocks are created by altering the structure and composition of existing rocks through natural forces, resulting in a neat new rock form.
A rock that forms when sediment is pressed and cemented together. Sedimentary rock is a type of rock made from small particles or fragments that have hardened over time.
Imagine trying to organize a cluttered drawer filled with various items like papers, pens, and small gadgets. This is similar to how sedimentary rocks form, when layers of sediment, like bits of sand, mud, and tiny fossils, accumulate and are compacted over time. Just as you press and arrange the items in the drawer to make them fit neatly and stay in place, sediments are pressed together by the weight of layers above them and eventually cemented into a solid rock, creating a structured, cohesive mass from what was once a chaotic assortment of materials.
The process in which rock is worn away and transported by water, wind, or ice is erosion. Erosion is when natural forces move bits of rock or soil from one place to another.
Imagine trying to keep a sandcastle intact on a busy beach, with people constantly walking by. Just as footsteps cause the sandcastle to slowly crumble and spread across the beach, erosion involves the gradual wearing away and movement of rock by natural forces like water, wind, or ice. In this analogy, the sandcastle represents the rock, the footsteps symbolize the forces of nature, and the spreading sand mirrors the transport of eroded materials to new locations.
A light-colored igneous rock, granite. Granite is a type of rock formed from cooled and solidified magma, made mostly of minerals like quartz and feldspar.
Imagine you're trying to find a unique gift in a store full of colorful items. Just like picking out that one special gift among many vibrant options, identifying granite involves recognizing its distinct light color and texture among various igneous rocks. Just as the gift stands out due to its unique features that catch your eye, granite is recognized by its light-colored appearance and mineral composition, setting it apart from other rocks formed from cooled magma.
A dark, dense igneous rock, basalt. Basalt is a volcanic rock formed from the rapid cooling of lava at Earth's surface.
Imagine trying to choose the right couch for your living room, only to find that the one you like is heavy, dark-colored, and incredibly durable, seemingly absorbing everything around it. This scenario is similar to basalt, a dark, dense, igneous rock that forms from rapidly cooling lava, making it both strong and tough. Just like your choice of couch, basalt is defined by its dense, robust nature and dark appearance, which results from its composition and formation process. Much like the fabric and design choices that define your furniture.
The size, shape, and grains of a rock. Texture. Texture is the feel or appearance of a surface, determined by the size and arrangement of its particles.
Imagine trying to fit all your groceries into a single reusable bag after a big shopping trip. Just as you have to consider the size and shape of each item to make everything fit efficiently, geologists examine the size, shape, and arrangement of grains in a rock to understand its texture. In this analogy, each grocery item represents a grain in the rock. The size of the item is like the size of the grain. The shape of the item corresponds to the shape of the grain. And how the items are arranged in the bag is akin to how the grains are packed together in the rock.
A deposit that hangs from the roof of a cave stalactite. Stalactites are icicle-shaped formations created by mineral-rich water dripping and depositing minerals from the ceiling of a cave over time.
Imagine a leaky faucet in your kitchen that slowly drips water onto the counter. Over time, if the mineral-laden water from the faucet evaporates, it leaves behind small deposits of minerals, gradually building up into a noticeable bump on the surface. Similarly, stalactites form when mineral-rich water drips from the ceiling of a cave and evaporates, leaving behind deposits that accumulate into icicle-shaped formations. Just like the mineral buildup from the faucet drip, stalactites grow from repeated mineral deposits left by evaporating water, showing how small, consistent actions can lead to significant formations over time.
A cone-shaped deposit that builds up from the floor of a cave. Stalagmite. A stalagmite is a mineral formation that grows upward from the floor of a cave as minerals from dripping water accumulate over time.
Imagine the frustration of dealing with a leaky faucet in your home where water drips slowly but steadily into the sink. Just like each drop from the faucet contributes to a growing puddle over time, stalagmites form in caves as mineral-rich water drips from the ceiling and deposits tiny amounts of minerals on the floor. In this analogy, the leaky faucet represents the ceiling of the cave. The dripping water is similar to the mineral-laden water in caves, and the puddle that gradually builds up is akin to the cone-shaped stalagmite that slowly forms upward from the cave floor.